Welcome to Tomorrow Unveiled, your destination for understanding the cutting edge of progress and what it means for our future. This week, we're taking a deep dive into the cosmos with our segment Beyond Earth, This Week in Space.
Oh.
And the first week of August 2025. Wow, it's delivered a flurry of really remarkable technological breakthroughs, stuff that's truly pushing humanity's space capabilities higher than ever. Our mission today is to unpack the most significant developments from just the past 7 days. We're focusing on how space tech is moving, from just concepts to actual operational capabilities. And this is happening even with all the geopolitical tensions in the background. We'll be pulling out the key nuggets of knowledge from the comprehensive research our dedicated research team has put together for you.
Yeah, and what's really striking when you look at the research this week is this clear pivot. It's a shift towards establishing a permanent, sustainable human economic sphere beyond Earth. These aren't just random events or small improvements. They feel interconnected. Part of a much bigger strategic push driven by, geopolitics partly, but also enabled by some seriously disruptive tech in manufacturing and operations. You're about to hear about some really fundamental changes.
Okay, so let's maybe unpack this a bit. I mean, the sheer energy, the investment pouring into commercial space just this last week, it's undeniable.
Oh, absolutely.
It really feels like things are speeding up, dramatically. The whole space economy.
Yeah, it does. And, our research team, they're really highlighting how you've got this convergence happening.
Right.
Mature, reusable rockets, which is huge, but also this growing field of in-space manufacturing. Still early days, but it's there. Add in the international partnerships expanding. Well, all that together is sort of forming the bedrock for genuine space industrialization.
So it's not just about getting up there anymore.
Well, it's about building something sustainable while we're up there.
And talking about acceleration, well, you got to talk about the big players.
Yeah.
SpaceX, for example. They just hit a massive reusability milestone.
The 450th flight-proven Falcon booster.
Yeah, 450. I mean, that's not just a number, is it? It feels like it fundamentally changes the economics.
Yeah.
Drastically cuts launch costs. What's the real impact of getting that routine?
That's a really key question. Think of it like this. When launch costs drop so much, it's not just saving money on the missions we already do.
Okay.
It unlocks entirely new kinds of missions, new industries that just weren't, financially possible before.
Like what?
Well, the mega constellations, obviously, but maybe widespread in-orbit manufacturing down the line, advanced space tourism, even initial attempts at asteroid mining. It just broadens the whole playing field.
Right. It democratizes access almost.
Exactly.
Yeah.
Changes who can afford to innovate up there.
That is a powerful shift. And at the same time, SpaceX also made progress on Starship propellant transfer tech. Successful static fire testing of Ship 37. Why is that specific tech so critical for going further out, like Moon or Mars?
Oh, it's absolutely vital because it lets you do missions that are just impossible right now.
Oh, so?
For those really ambitious trips, Moon, Mars, you basically have to refuel in orbit. You just can't lift all that fuel off Earth against gravity.
Gotcha.
So this in-space refueling, it's like putting gas stations in space. It transforms what we can do in deep space, makes bigger, more complex missions actually viable, economically speaking.
Gas stations in space. I like that. And this reusability, it feeds right into the mega constellations, doesn't it? SpaceX just passed 5,000 Starlinks in orbit. Global broadband is becoming a reality.
The build-out is rapid.
But what's really interesting, our research shows Amazon's Project Kuiper, their competitor, aiming for, 3,200 satellites?
That's the plan, yeah.
They're actually using SpaceX for some launches now to speed up their own deployment. What does that tell us?
It's fascinating, isn't it? It's a great example of what you might call pragmatic collaboration.
Right, even though they're competitors.
Exactly. The demand for launch is just so high, and the push for global broadband is so intense that even direct rivals are, working together when it makes sense. It shows the scale and the sheer speed of this new space economy. Competitors finding common ground to get the infrastructure built faster.
That dynamic is something else.
Right.
And it's not just the household names. Firefly Aerospace had a huge IPO this week.
Very successful, yeah.
On massive. Raised around $868 million, market cap over $8 billion. That shows some serious investor confidence in what people call new space.
It certainly does.
For our listeners, new space generally means these newer private companies shaking up the industry. What was it about Firefly or maybe the broader new space market that's driving that kind of valuation?
That's a really important point. Our research suggests that Firefly's earlier success, being the second private company to soft land on the moon back in March 2025.
Ah, right. That must have helped.
Absolutely bolstered confidence. But what's really compelling, I think, is how this IPO validates a certain investment model.
Okay.
You've got these integrated companies like Firefly, developing everything, end-to-end rockets, landers, the whole package.
Right.
That's attractive if you want broad exposure.
Makes sense.
But then you also see these disruptive component suppliers like India's Agnico Cosmos. We'll probably talk about them more later.
Okay.
Focusing on just one revolutionary piece of tech. So investors now have more choices, more ways to back this growth. They see space as, well, maybe less speculative now, more like a maturing market.
A maturing market.
Yeah.
That feels right. And speaking of maturity, NASA's Crew 10 mission. Historic splashdown off California.
First crewed Pacific splashdown for the Commercial Crew Program.
Right. And it's not just a cool first, is it? It says something about the reliability of those commercial spacecraft, like SpaceX's Dragon, transporting astronauts, including Russian and Japanese crew, seamless collaboration.
Absolutely. It demonstrates deep operational maturity. The fact that NASA is, increasingly comfortable handing over the keys for their most valuable asset, the astronauts, to commercial partners,
Yeah.
that's a profound philosophical shift. It basically cements the private sector as the main provider of crew transport to orbit for the U.S.
Which frees NASA up for other things.
Exactly. Lets NASA focus resources on pushing further out, deeper space exploration.
Looking ahead then, new heavy lift rockets are coming online too. ULA's Vulcan Centaur, Arianespace's Ariane 6, both lining up for big launches around August 12th. National security, weather satellites.
Yeah, these are crucial. We need that reliable heavy lift capability, especially with the West wanting multiple options. High launch cadence is key.
And related to that, the UK just granted its first ever space launch license to Skyrora. So Britain's getting ready to join the club of nations launching from their own soil.
That's another sign of the expanding ecosystem.
Right.
And the push for more heavy lift capacity, it's driven by the sheer demand. Constellations, future deep space stuff. It's about redundancy, resilience.
Right.
And what's also really fascinating is how Starship is already carving out its niche there. SpaceX just signed a deal with the Italian space agency, ASI.
Oh, yeah.
For what? To fly Italian science payloads on Starship's first commercial flights to Mars.
To Mars. On a commercial flight.
First time ever, a national space agency has booked commercial payload space to Mars on a private rocket. It just underscores how these commercial heavy lifters are stepping into roles previously only governments could fill, especially for deep space.
Okay, this is where, for me, it gets really interesting. Beyond just, lifting things to space, we're seeing fundamental changes in how we might build things, operate, even recycle in space. It feels like a new industrial revolution, but, for the cosmos.
Yeah, and if you connect that to the bigger picture, these breakthroughs are really ushering in an era of, let's say, scalable, automated, cost-effective production off-world,
Right.
which fundamentally speeds up our pace in space. It's a shift from just bringing everything from Earth to building things on demand right where you need them.
And leading that charge, India's Agnico Cosmos, they unveiled the world's largest single-piece 3D-printed rocket engine, Agnilet, made from Inconel.
That's right. A major achievement.
This fully integrated manufacturing approach, as they call it, radically simplifies assembly, cuts production time by over 60%, less weight, fewer potential failure points. What's the real game changer here? And they got a U.S. patent, too.
The game changer is how it totally disrupts traditional aerospace manufacturing. Instead of painstakingly assembling hundreds, maybe thousands of tiny, intricate parts, you print one solid integrated piece. It's not just cheaper and faster. It inherently makes the engine potentially more reliable because there are fewer joints, fewer welds, fewer places for things to go wrong.
Makes sense.
And that U.S. patent, that's a huge signal. It says the tech is globally recognized as genuinely innovative. It positions India as a serious player in next-gen propulsion, capable of challenging the established giants using these novel methods.
Imagine applying that print-on-demand idea to, parts for a moon base eventually.
Exactly. That's a long-term vision. It's a blueprint for in-space production.
Truly incredible. And robots.
Yeah.
Robots are becoming key, too. The Ichben mission on the ISS.
Fascinating experiment.
First successful collaboration between two independently developed robotic systems in orbit. Germany's AI bought Simon and Japan's Intball 2 drone. What does this small step really mean for building future outposts?
I wouldn't call it a small step, actually. It's a pretty big leap for automation in space.
Okay, why?
It proves you can have these distributed multi-agent robotic systems managed by just one human, even if the robots come from different countries, different designs.
Ah, so they got them to talk to each other, essentially.
Effectively, yes. The Isoban experiment shows that a common AI-driven interface can act like a universal translator. It makes a plug-and-play ecosystem of international robots a real possibility.
Wow.
That dramatically lowers the barrier for international collaboration on complex construction jobs, like lunar bases or orbital factories, makes it more agile, more efficient.
And things are getting more sustainable, too. Our research team flagged breakthroughs in 3D printing using recycled space debris, turning old satellite aluminum into new parts.
Exactly. That's the circular economy idea coming to space.
So orbital junk could actually become a resource.
Potentially, yes. This shift away from a throwaway culture towards reusable and recyclable is critical if we want long-term operations up there.
And we're also seeing leaps in propulsion tech, stuff to make travel faster.
Definitely. Several interesting developments. There's MagDrive Rogue, that's a solid metal propulsion system, getting ESA backing for satellites.
Okay.
Then there's a Russian plasma engine prototype being developed specifically for Mars, aiming to cut travel time significantly.
Big goal.
And a U.S. startup, Venus Aerospace, reportedly tested a rotating detonation rocket engine. So lots of different approaches, all aiming to cut travel times, increase payload capacity, basically opening up more of the solar system.
And for exploring those planets, NASA's Europa Clipper successfully tested its ice-penetrating radar during a Mars flyby.
Huge milestone for that mission.
Confirmed it can search for water under Europa's ice. What's the ultimate prize there?
Her ultimate prize is astrobiology, finding signs of life beyond Earth. Europa is considered one of the top candidates in our solar system because of that huge subsurface ocean. So this successful radar test, it's monumental. It confirms the instrument can actually see through potentially miles of ice.
Giving us a peek into an alien ocean.
Potentially a habitable one. It's about tackling that huge question. Are we alone?
Okay, so bringing all this together, what does it mean for actually building a permanent human presence out there? It feels like we're moving past just exploring towards actually living and working off Earth.
That raises the big question, doesn't it? How do we actually do that reliably, long term? And the developments this week across nations, across commercial players, that they show this strategic urgency to build the foundational infrastructure.
The plumbing and wiring of space, almost.
Kind of, yeah. Power grids, habitats, logistics chains, the basics you need to set up shop anywhere.
And nowhere is that clearer than with lunar power. Our research points to NASA fast-tracking a 100-kilowatt nuclear fission reactor for the moon by 2030. That's a big jump from earlier plans.
A very substantial increase, yes.
What's driving that aggressive timeline? And why lean so heavily on commercial companies to build it?
Well, what's fascinating here, and our research team highlighted this, is the strong geopolitical driver.
The competition aspect.
Right. There's concern among U.S. officials that whoever establishes the first reliable industrial-scale power grid on the moon, well, they could potentially declare large keep-out zones.
De facto claims.
Exactly. Functionally, like claims on valuable territorial resources, which bumps up against the spirit, if not the letter, of the 1967 Outer Space Treaty about space being for everyone.
So speed matters.
Speed matters. By relying on commercial partners, NASA hopes to leverage private sector speed and innovation to, frankly, outpace the joint China-Russia lunar plans. And having that power enables the big stuff, like ISRU using lunar resources on site.
ISRU, in situ resource utilization, using what's already there.
Precisely. Game changer for sustainability.
And closer to home, in Earth orbit, NASA tweaked its strategy for replacing the ISS, moving to multiple funded agreements for commercial space stations.
The CLD program, Commercial LEO Destinations. Yeah.
Companies like Axiom, VAST, Blue Origin Sierra Space, Starlab, all pushing their concepts. What does this shift signal about NASA's role?
It signals a profound philosophical evolution for NASA. They're consciously moving from being the primary developer of space infrastructure
To be more of a customer.
a strategic acquirer, is the term they use. Essentially, yes. They're outsourcing the design and build of these critical EO stations, letting the private sector innovate, compete, while NASA sets requirements and acts as a key tenet.
Powerful validation for the commercial sector.
Absolutely.
Meanwhile, China's program, they just did the first full-scale test of their new crewed lunar lander, Lanyu.
Critical step for their goal of landing taikonauts by 2030.
And they're planning that international lunar research station with Russia, aiming for 2035, maybe even with nuclear power, too.
These parallel tracks really highlight what our research team calls the new space race. It's undeniably underway. US and the China-Russia bloc both pushing hard for lunar outposts, lunar resources. Now, this competition, it definitely speeds up innovation,
Oh, yeah.
but it also raises really tricky questions about global governance, resource rights, potential claims, stuff the Outer Space Treaty isn't really built to handle smoothly.
Needs an update, maybe.
Potentially, yeah, or at least some new interpretations.
And it's not just the big bases. It's the logistics to support them. We saw progress in responsive space ops, Rocket Lab's Vixie-2S HAZ mission,
Quick turnaround launches, yeah.
and advancements in refueling in orbit.
Yeah.
Orbit Fab's fuel port got approved as a standard.
The RAFTI port, yeah. A standard interface is huge for interoperability. They plan a fuel depot launch for 2026.
Or satellite servicing from Northrop Grumman, Astroscale's debris removal system. Well, it's all part of keeping things running smoothly up there, right?
Exactly. All these pieces build that robust, resilient, logistical backbone you need for long-term operations. Just like on Earth, you need gas stations, repair shops, tow trucks.
Space tow truck.
Sort of. You need refueling, servicing, debris clearing. It's building the essential infrastructure. And tied to that ISRU idea, experiments are moving forward on 3D printing structures directly from simulated moon dust, the regolith.
Using local materials.
Critical for building large things like habitats, radiation shields, without hauling everything from Earth at enormous cost. That's how you get towards permanent, self-sustaining outposts.
Okay, it sounds like we're really rocketing towards becoming multiplanetary, but progress like this always comes with hurdles, right? Big ones.
Yeah.
What are the key challenges our dedicated research team flagged that the community is grappling with?
Yeah, this is where we need that critical thinking. The momentum is fantastic, truly incredible, but we absolutely have to acknowledge the formidable technical, safety, and geopolitical complexities. They have to be managed for this to succeed sustainably.
And one of the biggest flashing lights seems to be orbital traffic and debris. These mega constellations, thousands, soon tens of thousands of satellites. It raises real concerns about congestion, collision risk, that whole Kessler syndrome nightmare scenario.
It's a very real concern, a cascading effect where collisions create more debris, leading to more collisions.
Making orbits unusable.
Potentially, yes. So innovations like Astroscale's debris removal are crucial. But we also desperately need updated international guidelines for deorbiting satellites at end of life and much better space traffic management coordination.
Because the sheer number of objects is unprecedented.
Completely. And the regulations are struggling to keep up. Without global agreement and active removal, we risk polluting our orbital environment for generations.
And the technical and safety hurdles for these really ambitious projects, they're immense too. Take the lunar nuclear reactor. Challenges like getting rid of heat in a vacuum needs big, heavy radiators, staying within mass limits for the landers. And then what do you do with the spent nuclear fuel? Safely, permanently.
These are major engineering challenges, and launch failure is always a risk, especially with something like a reactor. It's not trivial.
No. And even the new rockets, Vulcan, Starship, revolutionary, yes, but still need rigorous testing. They've had anomalies, needed fixes, plus environmental impacts to consider.
And for human spaceflight, safety is paramount. Constant vigilance, managing weather for launch and recovery, dealing with long-term radiation exposure, life support reliability, emergency escapes for deep space. The list is long.
Then you have the bottlenecks on the ground. Regulatory hurdles like FAA clearances taking time, launch pad availability. You mentioned Skyrora got the UK license.
Yeah, but the spaceport Saxavord is reportedly booked solid until 2026.
Right. So getting a license is one thing, getting the launch slot is another. Plus, regulating radio frequencies, orbital slots, and export control rules can complicate international partnerships, too.
These are all friction points. They can slow things down, even the best plans. The legal and regulatory frameworks just weren't designed for this volume and speed of activity.
And finally, circling back to geopolitics. That new space race between the U.S. and the China-Russia bloc over the moon, it puts real strain on the Outer Space Treaty from '67. Concerns about keep-out zones, creeping territorial claims.
It's a major tension point. How do you balance that intense competition with the spirit of cooperation we've historically seen, like on the ISS? It's a huge ongoing challenge.
Now, cybersecurity threats to space assets, that's a whole other layer.
A critical one now, yes. National security implications are huge.
So wrapping up an incredible week, what's the main takeaway from all the research our team pulled together?
I think the clearest signal, the thing that stands out most, is this undeniable shift. We're moving past just conceptual exploration towards the actual operational establishment of a sustained human presence beyond Earth. It's the convergence, the commercial drive, the technological leaps, and, yes, the geopolitical push. It's all coming together to genuinely accelerate the timeline for living and working off-world.
What a week. We covered so much. 3D printed engines, collaborating robots, huge lunar power plans, commercial growth.
Yeah.
Let's try to summarize the key takeaways. First, the space economy. It's maturing fast, attracting serious money, empowering commercial players to lead the charge. It's changing who gets to go to space and what they can do there.
Absolutely.
Second, those revolutionary advances in manufacturing, in robotics. They're making operations in space more feasible, more automated, cheaper than we could have imagined just a few years ago, paving the way for actual off-world industry.
True in-space capabilities.
Third, those big infrastructure projects. Moon bases, new space stations, they're moving forward with really aggressive timelines, driven by both huge commercial opportunities and national strategic goals.
A powerful combination.
And finally, all these giant leaps forward. They come with equally giant challenges: orbital sustainability, technical complexity, rules that need updating, geopolitical rivalries. The whole space community is actively working on these, but they are significant hurdles.
Definitely. And that leads to maybe a final thought to leave people with. Okay. This push to establish, as some call it, facts on the regolith, meaning tangible infrastructure, actual operations on the moon and beyond. That's going to profoundly shape the legal, the political, the economic landscape of space for generations. As humanity really starts to expand beyond Earth, how are we collectively going to govern and share this enormous new frontier? That's maybe the question for the next century.
The huge question indeed. And we love hearing your thoughts on it. Whether you're watching on YouTube or listening on your favorite podcast app, definitely leave a comment. Let us know what you think about this week's Beyond Earth updates. If you're finding Tomorrow Unveiled insightful, please take just a moment to like this video on YouTube, subscribe to the channel, and definitely hit that notification bell so you never miss an update on the future. And if you're listening on a service like Apple Podcasts or Spotify, we would be incredibly grateful if you could leave us a rating and a review for Tomorrow Unveiled. It genuinely helps us reach new listeners. Thank you for joining us on Tomorrow Unveiled, where we bridge the gap between today's breakthroughs and tomorrow's reality. See you next time.